So today we're going to crack the code on two really basic questions about all the 3D objects around us. How much stuff does it take to cover them, and how much stuff can you fill them with? It's the difference between wrapping a present and filling up a water bottle. Let's dive in.
All right, picture this. You've got a gift to wrap. The question you're asking yourself, probably without even thinking about it, is actually a math problem. How much wrapping paper do I need to cover the entire outside of this thing? That's our starting point.
Now, let's flip that idea on its head. Think about a huge water tanker. Here, you don't care about what's on the outside, right? The real question is all about the space inside. How much water can it actually hold? This is a totally different measurement.
And that, right there, brings us to our two big ideas. Surface area, that's the wrapping paper problem. It's the total area of all the outside surfaces, and we measure it in square units, like centimeters squared. Volume is the water tanker problem. It's the total space an object takes up, and we measure that in cubic units. So one is about the skin, and the other is about what's inside.
So, let's start with one of the most common shapes in our world. It's time to get into our first section, mastering the box. A cuboid is really just a fancy name for a box. It's a 3D shape where every single one of its 6 faces is a flat rectangle. Your phone, a book, a brick, yep, they're all cuboids. And this is super important for things like packaging. If you know the surface area, you know exactly how much cardboard you need, and that saves a ton of material and money.
Now here's a really cool way to figure this out. Instead of just memorizing a formula, we can build it from scratch. See, a cuboid has 3 pairs of faces that are exactly the same size. So we just find the area of the top and bottom, then the front and back, and finally the 2 sides. And when you add all of that up, you get this simple, elegant formula. It's just 2 times the sum of the areas of those 3 unique pairs of faces. The key thing here isn't just memorizing the letters, it's understanding that you can build it yourself, logically, just by looking at the box. And the volume? Well, that's even easier. To figure out how much space is actually inside that box, you just multiply its 3 dimensions together. Length times breadth times height. That's it. Simple as that.
All right, let's move on to our next shape. This one's a bit of a curveball, literally. Time for section 2. Let's try to understand the can.
Now, cylinders are interesting because they have both flat parts and a curved part. The curved surface area is just that bit that wraps around the middle. A perfect example is the label on a can of soup. But the total surface area includes that label plus the 2 flat circles on the top and bottom.
Finding the volume of a cylinder might seem tricky at first, but there's a really simple secret to it. You just start with the base. The base is just a circle, right? And we know the area of a circle is pi times the radius squared.
Okay, so once you have the area of that flat circle at the bottom, all you do is give it height. Imagine you're stacking up hundreds of paper-thin circles, one on top of the other. The total space they take up is just the area of one of those circles multiplied by how high you stack them. And that gives you the volume, pi r squared h. Okay, enough theory, let's make this real and put the formula to the test. We've got a cylinder here with a radius of 10.5 centimeters and a height of 8 centimeters. Come on, let's find its volume together.
So first step, we just take our values and plug them straight into the formula we were just talking about. We'll use 22 over 7 for pi, so we get 22 over 7 times 10.5 squared times 8.
Now before you panic and reach for a calculator, we can actually simplify this. Check it out. 10½ divides by 7 really cleanly. It gives us 1½ All of a sudden, this calculation looks a lot less scary.
From here, it's just straightforward multiplication. 22 times that 1.5 gives us 33. So now we're just left with 33 times 10.5 times 8. We're in the home stretch. And when we punch in that final calculation, we get our answer, 2,772. But don't forget the most important part, the units. It's cubic centimeters because we've measured that entire 3-dimensional space inside the cylinder.
So, we've played around with formulas, we've crunched some numbers, but let's zoom out for a second and ask the big question. Why does any of this actually matter outside of a math class? Well, the truth is, these ideas are absolutely everywhere. They're used to figure out the capacity of the water tank that supplies your home, the design of the box that your last online order came in, and the amount of material needed for pipes and rods in manufacturing. Pretty much any big engineering or construction project relies on these fundamental concepts. Understanding surface area and volume is literally how we build our world.
And that brings us to the end. But I want to leave you with a final thought, a little challenge. Just take a quick look around whatever room you're in right now. Can you spot a can, a box, or some other simple shape? Because the really cool part is you now have the tools to not just see it, but to truly understand the space it fills. You can calculate its volume. How cool is that?